For the second section of this problem, we were tasked with showing that the projectile can hit any point within this specified parabola, but not anything outside it. The equation for the parabola was given by x squared plus ry minus r squared, where r is the range, which is given by v initial squared over gravity, and x and y are just x and y along this axis here, with whatever units you choose. So, for this, we need to show that the maximum range is given by this, but you can't exceed it. So what is most important to realize is that since this range takes into account initial velocity and gravity, it doesn't matter what you change those two values to be, larger, smaller, what, this parabola will change to match it. Therefore, the range, which is the maximum possible distance that you can reach at the most efficient angle, is always going to be touched by that specific angle. So, firing a projectile at 45 degrees, let's pretend that is 45 degrees, will always result in a shape that looks like a much better drawing of that. This is because 45 degrees is the most efficient angle of firing for maximum distance, and because the range is the maximum distance that you can reach. Now, since this parabola gives basically all the possible points that you will touch firing this projectile, if you fire it at this certain angle, you will do something like that and touch it at that edge and then fall down to here. Basically, it doesn't matter what angle you fire at, you will touch one point on this parabola and then fall through to the x-axis. So this parabola is showing us all the possible largest points from the origin at that specific angle that you can reach, and then all of the area underneath that you can hit while falling through. So this shows that you can't hit anything outside of it because the maximum distance possible is bounded by the range, and you can hit any point within it because you can hit any point on this line